Okay, so we have this next question right here. It says that the diagram shows a machine used to launch tennis balls in a horizontal direction. The machine is on frictionless wheels. Before a tennis ball is launched, the machine is stationary. Explain in terms of momentum why the machine starts to move as the ball is launched. Okay, it's very simple. Let's first understand what is meant by the frictionless wheel. The machine is on frictionless wheel, right? It means that there is no external forces, right? If there is no external forces, then it means that the total momentum is conserved. What is the momentum's rule? There should be no external forces, right? So the total momentum before is equal to the total momentum after, right? Because there is no external forces. Just mention that. The first thing you will mention here. You can either say the total momentum is conserved because of no external forces, or you can just write the whole thing, which is total momentum before is equal to the total momentum after, because there is no external force, right? Now let's go to the next point. It says that before a tennis ball is launched, the machine is stationary. Okay, so if the machine is stationary, then the total momentum before is zero, right? There's nothing happening, so it's zero. So it means that if total momentum before is equal to total momentum after, that means before is zero, then after will be also zero. That means that the whole process of momentum, that the whole process that is actually happening is zero. So we will say that total momentum is zero, right? So now the thing they ask us, like, why the machine starts moving then? If the total momentum is zero, it is because that the ball momentum is not zero after the machine, launches it. Like it has momentum, so machine has to make it equal, right? By going into the opposite direction to the ball's direction, and when you just basically add them up, the whatever the direction of motion you take, maybe right side as positive or left side as positive, you will add them up. One will be a negative value, one will be a positive value, right? And when you add them up, they will equal to zero. So you just have to explain that, right? Final momentum of the machine is not zero because the final momentum of the ball is not zero. Also add this additional point that they're going in the opposite direction, and they are going in the opposite direction. Simple as that. Explain everything so that you don't, miss any valuable marks. Okay. So it's very simple. Understand the statement and just reply the statement. Like you can see, I have like used nothing outside this question. I have used the question statement and converted it into my answer. Simple as that. So this is your final answer. Okay, so the next part says that calculate the velocity of the machine just after the ball is launched. Okay, velocity is given, mass of the both thing is given, right? So first step, identify what values is given. So we have velocity of the ball, right? And we have mass of the ball. We need to find, and we have also the mass of the machine, right? Machine. And we need to find the velocity of the machine, okay? Simple. We can use the conservation of momentum, which is m1 u1 plus m2 u2 is equals to m1 v1 plus m2, sorry, m2 v2. And from the previous part, if you remember, this whole thing is actually 0 because the machine was stationary and the ball wasn't launched before, right? So this whole thing is 0. So you can say 0 is equals to m1. Let's say your m1 is ball and m2 is machine. Okay, so you have 0.056, right, times the velocity of the ball, which is 4.5 v1, plus m2 is the machine mass, which is 2.9, and you have velocity, which is you need to find, right? And I would like to mention a second point as well. If you remember that this is your machine, let's say this is your machine. I'm not good at drawing, so let's say this is your machine with these wheels, right? And you draw, this is your ball, right? Your ball is going right, but your machine will go to the opposite side, right? So that it can be your total momentum, it matches your total momentum before. Okay, so it's up to you whatever the direction of motion you want to take as positive. So I will take this positive value towards the right side, so my machine moving to the left side will be negative, right? So I can just add this negative sign right here. Okay, just add it here, or remove the plus sign and add negative here. It's up to you. So it will be 0.056 times 4.5, negative sign, you shift it on the left side, and now you will divide this 2.9, negative 2.9 is equals to Vm, and your Vm, which is the velocity, it will be equal to 0.0869. Okay, if you round it off, you will get 0.087 meter per second. So 0.087 meter per second is your final answer. Yeah.